it. Through it, it represents for material. Okay, that means it is the ability, how much ability the material have to permit all the magnetic field. That means if this is the material, there is a no chances that all the magnetic field lines can pass. There is a no probability, that is all the magnetic field lines can pass through this material. Some of the magnetic field lines can avoid this. Therefore, it tells us about how much it can permit the magnetic field lines of force through it. That is the permeability. That means the permission of the magnetic field lines to enter into our material which we have placed under the external magnetic field. Therefore, it is represented by the symbol nu. And the more magnetic permeability means the more magnetic field lines are passing. Okay? When we say the magnetic permeability of material is more, when we say, that means the magnetic field lines passing from this material is more. Because of that, there is a more magnetic permeability. Therefore, in this, some of the terms you get, that is what? The relative magnetic permeability. What do you mean by this? This is generally given by this, that is relative permeability is equal to mu by mu naught. The ratio of this is our relative permeability. That means this mu is what? The magnetic permeability of the material to the magnetic permeability of the free space, the ratio of these two. That means the material permeability as well as the space permeability, the ratio of these two, it becomes our relative permeability. Therefore, you can write it as the degree, here I write, to which magnetic field can penetrate permit material is called what? Relative magnetic permeability. The degree, the extent to which the magnetic field can penetrate this. That means if I draw the more magnetic field, okay, here the more magnetic permeability of this material it has, because the more magnetic field lines are permitting. That means it is passing through this material. Because of that, there is a more magnetic permeability. The degree to which the magnetic field can penetrate or permit a material to pass through this is known as the relative magnetic permeability. And this relative magnetic permeability what do you mean by the mu naught? As I told you, this is the magnetic permeability of the free space. This is actually the constant, that is 4 pi into 7 per meter, or you can say per ampere per meter. Okay, this is the term constant, that is mu naught, that is permeability of the free space, it is given by 4 pi meter to the power of. What do you mean by the relative permeability? That is mu r. This, if I talk for air, what is the relative permeability for air means? It has 1. What is the relative permeability for soft iron? That is 8000. Okay, the relative permeability. That means the relative permeability depends upon the material to material. Different material have the different relative permeability of the material. Therefore, for A, the relative permeability is 1, but for the soft iron it is 8000 times strong. That means the 8000 magnetic field lines can pass through that type of material is our soft iron. Whereas in case of the air, only the one magnetic field lines is passing from that air. Okay. Therefore, this is about the magnetic field lines. If in terms of this is in terms of the magnetic permeability of the material to the magnetic permeability of the free space. If I talk the relative permeability of the material in terms of the magnetic field, in that case, that is the relative permeability of the material in terms of the magnetic field, that is D by B naught. That is what? This is our B, that is magnetic field of the material, and this B is the external magnetic field. Therefore, the relative permeability in terms of the magnetic field, I can write it as this. It is the ratio of the magnetic field of the material to the magnetic field of the free space, that is B naught. That is our external magnetic field. Okay. The relative permeability in terms of the magnetic field, the relative permeability in terms of the permeability of the both medium, that is material as well as our free space. This is our magnetic permeability of the. Okay. When we say the magnetic permeability is more, yes. When we say means, as the more number of magnetic field lines, if it is passing from this material, in that case we say that it is a more magnetic permeability of the given material. That means here the bifurcation not only by the susceptibility, even though in terms of the permeability also we can bifurcate the different types of materials. As I told you, if the relative permeability, okay, is less than 1, if the relative permeability is greater than 1, if the relative permeability is still greater than 1, okay, this is going to. In the last class, we have studied about the magnetic permeability, okay, of the material as well as about the free space. Therefore, generally, it depends. The material are going to bifurcate. That is what we call it as the substance classification. That is depending upon the relative permeability. That is what the relative magnetic permeability. If it is less than 1, this type of material is our diamagnetic material. If the relative permeability is less than 1. In terms of susceptibility, if I talk, that is the susceptibility may be positive or negative. Okay, it depends upon the what type of material we are taking. When we say the diamagnetic material, when the relative magnetic permeability is less than 1, in that case, that material is diamagnetic. If the relative magnetic permeability is greater than 1, in that case, this type of material, which we call it as the paramagnetic material. Okay, in terms of the susceptibility, if I talk, the negative susceptibility, which indicate our diamagnetic material. If the susceptibility is positive, in that case, paramagnetic material. If the relative magnetic permeability is still greater than 1, that is our ferromagnetic material. Okay, here the xi is negative, here the xi is positive, low, and here the xi is also positive, and the susceptibility is low, whereas it is high susceptibility. Okay, that means on the basis of these, that is the relative magnetic permeability less than 1, those type of material we call it as the diamagnetic material, or else I can say we observe the susceptibility is negative, in that case it is again the diamagnetic material. The relative magnetic permeability is greater than 1, those type of material, it comes under the paramagnetic, or else the susceptibility is positive and low, in that case it is the paramagnetic material. If the relative magnetic permeability is greater than 1, in that case those type of material is our ferromagnetic material and the susceptibility is positive and it is a high. Okay, so this is what the different substances are classified on the basis of the relative magnetic permeability as well as our susceptibility. If I talk in terms of the flow chart, in terms of the flow chart, if I talk classification of magnetic material. So in terms of flow chart, just I do this. This is our permanent dipole. If the material has the permanent dipole, if you say yes, if you say no, what happens? If any material which is having the permanent dipole, in that case, if say yes, those type of material are ferro, antiferro, ferri, magnetic. If no, that means the material which does not have the permanent dipole, in that case we call it as the diamagnetic. You can say this is a diamagnetic, that is diamagnetic material. Okay, that means it is depending upon the permanent dipole. If the material have the permanent dipole, in that case those type of material comes under the para, ferro, antiferro, ferri, magnetic materials. If the material does not have the permanent dipole, that is what no, in that case it is diamagnetic material. If another, that is what, in case of the material is permanent dipole, as what about the alignment of the material? Alignment of dipole. How is the alignment of the if the alignment is uniform, if the alignment of the dipole is non-uniform, in case of the alignment of dipole are same or they are uniform, in that case these type of which comes under ferro, antiferro and ferro. In case of non-uniform, non-uniform means all the magnetic dipole moments are aligned in random. Okay, in that case it is just a parallelism. Okay, if permanent dipole having the material having a permanent dipole, their alignment of the dipole is uniform. What about the direction of this? The direction of dipole. Whether the direction is same or not. If the direction is opposite, in that case the material are antiferro and ferro. If they are opposite, that means the direction of the dipoles are opposite. Those type of material is antiferro and ferri. If they are same, direction is same. Same in the sense along the external magnetic field. If the dipole moment is along the external magnetic field, in that case it is our ferro. Okay, this is another what are the magnitudes if they are opposite. Okay, if the directions of the dipole are opposite, it comes under the antiferro and ferro. If the directions of the dipole are same, that means along the external magnetic field alle hogta ide ನಮ್ಮ magnetic dipole moment nu andre, in that case it is ferro. In case of, that is here I write magnitudes of the dipole. The continuation of this, okay, this is our continuation of that. If the magnitudes of the dipole are different, like this, the magnitudes of the dipoles are different, those type of material which comes under the ferro. If the magnitudes are same, in that case it is our anti-ferro. Okay, so here the classification of the magnetic materials is based on the permanent dipole, it is based on the alignment of dipole, it is based on the directions of the dipole, and also it is based on the magnitudes of the dipole. In case of the permanent dipole, if material having the permanent dipole, in that case the materials are this. If they are not permanent dipole, these are all the diamonds. Whereas if they are permanent dipole, these are the material. If in this material, if they are aligned of the dipole moment, how they are aligned the dipole, whether they are in uniform or non-uniform. If they are uniform, those are all the ferro and antiferro it comes. Whereas the alignment of dipole is non-uniform. That means in random way, the magnetic dipole moment are arranged in random way in case of the para. If the alignment of dipole is uniform, what about the directions of the dipole? Okay, whether ನಾನು ಎಕ್ಸ್ಟರ್ನಲ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ನ ಈ ಕಡೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್ ಈ ಕಡೆ ಇದೆಯೋ ಅಥವಾ ಅಪೋಸಿಟ್ ಇದೆಯೋ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್. ದ ಡೈರೆಕ್ಷನ್ಸ್ ಆಫ್ ದ ಡೈಪೋಲ್, if they are opposite to our applied magnetic field, those are antiferro and ferro. If the directions of the dipole are same, in that case it is ferro. Along with this, if the directions of the dipole they are opposite and same, those are the material. If the magnitudes of the dipole is different, that means as I shown here, the magnitude of this dipole and magnitude of this dipole are totally different. If they are different, those type of material we call it as the ferro. If they are same, that means the magnitudes are same inside, in that case it is our anti-ferro magnet. This is how the classification of the magnetic materials. In the next class, we shall see the relation between the terms, that is magnetic field, the susceptibility, as well as the mean. These three terms, how they are going to relate each other. That is magnetic field, magnetic susceptibility, and the magnetic permeability. After this, we shall study one by one the different magnetic materials, that is diamagnetic material, paramagnetic material, and the ferromagnetic material. On what it is based on means, it is based on these. Okay. Step by step we shall study in the next class the properties of the diamagnetic mama, properties of the paramama, and the properties of the ferro.